So this is G485 homework booklet question 1. Start off with a straightforward definition question. Capacitance is for charge per unit potential difference. Move on to part B. We've got a diagram showing a circuit with a resistor and the capacitor. We've got the capacitance we're given there, and we're told that switch 1 is closed, so that is becoming a closed circuit there. With S2 left open, in other words, we're simply connecting the cell to the capacitor, so we can charge that capacitor. And we're asked, given the capacitance, and then we're asked to calculate the charge stored on the capacitor. Simple Q equals CV. Q equals CV. There's the capacitance, 4.5 times 10 to the minus 6. C. There's the PD, V, 6.3. We end up with 28. Now we've got to be careful here because they've asked for it in microcoulombs, so I've not put in the times 10 to the minus 6, because it's 28 times 10 to the minus 6 coulomb, which is 28 microcoulombs. And the energy stored in the capacitor, I could use a half QV, but I'm always happiest when I'm only using data that's come from the question, so I'm going to use a half CV squared. A half, there's the capacitance again, there is the PD squared. So far very straightforward capacitance question. So we're now told that switch 1 is opened and switch 2 is closed. Let's go back and check on the diagram what exactly that's going to mean. Go back to the diagram and see if I can get rid of that. Nope. Anyway, so we're closing that switch, and so we're opening this one back up, so that we've simply now got the capacitor connected to the resistor, discharging through the resistor, and so come back down to the questions. Describe an exchange in terms of the movement of the electrons, how the potential difference across the capacitor changes. So when we were here, we have the battery, and we've got the short side is negative, so that's going to be giving out electrons, so going to be moving electrons onto the bottom plate. This side is positive, we'll have taken originally electrons off that plate, so I've got electrons on the bottom. And now that I've opened that circuit up and closed this circuit here, so now this is the circuit we're looking at, those electrons off the bottom plate are going to flow around into the wire. Electrons in the wire are going to flow onto the top plate. So I've got the electrons flowing anti-clockwise in the circuit. That means that the charge stored will be dropping, and the PD drops. Because we've been asked to describe what happens, we can throw in that detail that the PD drops exponentially. And it says the energy stored in the capacitor decreased to 0, and asks you to state where the initial energy has dissipated. Stored in the capacitor is dissipated, and it's dissipated obviously, I hope, as heat, and that will happen in the wires and in the resistor, in fact, and they're happy for you to use either of those. Move on to part D. The capacitor is now, instead of connecting it up to another resistor that we have there, we're going to connect it up to another capacitor. So switch 1 is closed, as we had before. That creates my initial charging onto the 4 microfarad capacitor. And then again, switch 1 is opened up, switch 2 is closed. So we've got these two capacitors connected in parallel. And we're asked to calculate the total capacitance of the circuit. So I've got two capacitors in parallel. And so that's nice and simple. The capacitances are simply added, 4.5 to the 1.5, and we end up with a capacitance of 6. And then the interesting question is to calculate the final potential difference across the capacitors. So we charge it up to 6.3. What's the PD going to be when I discharge it? The key here is that it is the charge that is conserved. It's the charge that's conserved. So it's still a Q equals CV, basic capacitance equation. Q is that 28 microcoulombs I had right back earlier. that we always had stored in, and the capacitance is what we've just worked out here, the 6.0. So from rearranging this, V will be Q upon C, Q 28 microcoulombs, C 6 microfarads. I've missed off the 2 times 10 to the minus 6s, and that works out there. But as I say, the key thing is they're working out what it is that's conserved, because it's reasonable to think both in terms of, well, surely I've got the same PD, but no, it's a number of electrons essentially that we've got shifted around in that circuit. That's what I can't change. So it's the charge that's conserved. So it's still that 28 microcoulombs that we first calculated way back in the question. So that's G485 homework booklet question 1. No, it's not. It's homework question 5.